Hello, can you hear me? Yeah, can you hear me? Let me know in the comment section. In the chat, I mean. Okay, then I think we can begin. So then is the video is lagging, right? The stream is lagging. I don't know why. So okay, let me try. Whatever happens, let me know in the chat session. All right, I'm looking at it. Okay, can you see? Okay, I think everybody can see them. So let's begin with the assignment 6. So this is fixed pivot problem. The question says design a 4-bar mechanism to give a 3 position shown in figure 3 using the fixed pivots OA and OB. Then you're supposed to build a cardboard model and determine the toggle Determine the toggle positions and the minimum transmission angle. And then add quick return driver bias. That's the time ratio 1:1.4. Okay. So let's get into it. So yeah, I know, but can you follow up? I understand it's lagging, but can you follow up? All right, sure. So we are going to work on this. which is a fixed pivot problem, or a specified fixed pivot problem. Now you could see that on a diagram you've been given some numbers, right? So these numbers are there such that if you want to transfer this diagram to, let's say you want to redraw this on a white sheet, then you have to use these numbers to reorient, no, just transfer them from here to here. All right, so under normal circumstance we should use something like AutoCAD to draw these links and then print them before we work. All right, now you can choose to work on it, but because of the numbers it will make your work very messy, right? So I would want to transfer them onto the page, and this is what I'm going to do. Just align the sheets on one of my A4 sheets. I hope you can all have your questions and then solve with me. All right, don't just watch, have your assignment by your side and also be working as I do. Any question you have, let me know in the chat session and I'll respond to that. So instead of redrawing them, I will just use the divider to locate my points. So this is for OA, OB. And I'll locate for A1, B1, A2, B2, and then A3, B3. All right, so having done this, I will now come and then, so this is for OE, OB, and then A1, B1 is here. Then A2, B2, and then A3, B3. All right, so A1, B1, A2, B2, A3, B3. All right, so okay, so this is what we have now. Let me label this one OA, OB. So now, from our understanding, we have to, our understanding with fixed pivot method, we have to relocate the other positions. First off, we will assume the fixed pivot, the specified fixed pivot as rather the moving link, and then use triangulation method to locate the other two positions. Then we can design the workout, wait for that, and then when we finish, we do how do you call it, link transformation. All right, so knowing that OA, OB is our specified fixed pivot, I want to make it a link. All right, then I'll use triangulation method. So let me just use some short dashes. So with A2, OA, then B2, OA. So I will locate. All right, so let me just, instead of using OA and OB, well, we can use that, or I can just make this one E and this one F, anyone you want. So you use your compass, you pick the distance from A to OA, then you come to A1, you make an arc, then you come to B, OA, you come to B1, you make an arc. So where it meets becomes our OA prime, or we can make it E2. So this one will become E1. Any one of your choice. Great. Then you will do for F2. So you join this short dashes, this one also with short dashes. Then you measure A, O, B. Then you come to A, make an arc. Then you come to B, yeah. Make an arc. All right, I'm coming. So A, O, B. It's an arc. And then B, O, B. Okay. So the BOB, this triangle can only meet at this point. And where this one meets is far away. I mean, let's check the distance first. So from here to here is 6.9. Oh, okay. The same. All right. So this one will meet somewhere here. So you make this one F2 or OB prime. So that will give you the second position for the link E1, F1. Don't forget, we have just changed the OA, OB to variables E and F so that writing them will be easier for us. So here, our OA prime will become E2, and then our OB prime will become F2. Okay, so now that we are done, we will go and use triangulation with A3, B3, and then find the position for the third position for the specified link, specified fixed pivot. So that's to join A3 to this, and then B3 as well. All right, so A3 to E1, B3 to what? E1. So you pick A1, E1, you come to, sorry, A3, E1, you come to A1, you make an arc, and then B3, E1, you come to this. Okay, hey, it's meeting somewhere there. So we have E3 somewhere here. Then we join A3 to F1, B3 to F1. If you have any question, let me know in the comment section, please. The charts, I mean. Then pick this, you come to A1, come on. The lines are very messy, so just have to stick with the method. So A, F1, we come to U1, make an arc, and then B, F1, we come to B1, make an arc. So that one also met here, and I'll give you your F3. So if you joined, you have E3, F3 here. So our three links, we have the U1 F1 link, U2 F2 link, and then E3 F3 link. So now that you found the three positions for the specified ground link, the next thing is to design a rocker output for the new links that you've generated. So we do that by joining. Now my work is very messy, so we just have to follow what I say. All right, so now we just have three links: U1 F1, U2 F2, E3 F3. We're just going to follow the normal process of drawing a rocker. You join E1 to E2, E2 to E3, then you do the bisection, F1 to F2, F2 to F3, and do the bisection and locate the pivot point. And that's what I'm going to do. So if you are following, you can do this at your end. And also, if you have anything, let me know. If you have any question, let me know in the comment section. Okay, so we join E1 to E2 with short dashes, and then E2 to E3 with short dashes. Then we bisect them. And then we come to E2, E3. Okay, so looks like it won't go on the page. That's what I'm going to do. Let me just have a. So what in your work, what we can do is that, I mean, this question hasn't been solved before as I began. So what we can do is that maybe instead of, maybe that one too had gone over, maybe you can just reduce the length. See, they gave us the values, right? So you can use a scale to scale them down, all right, so that it can fit the page. So for the sake of the work we are doing, I just want to extend the sheet a bit and then do it on it. Okay, so this will give us the fixed pivot for E. So we can label that, say, O2. No, we have this. Let's make it G, right? So you connect U1 to G. E2 to G, and then E3 to G. Okay, now next is to next is to locate the center for F. So that's we join F1 to F2, F2 to F3. So F1 is here, F2 somewhere here, and then F3 is here. All right, so F1, F2, and then F2, F3. F2, F3, more than half. All right, then we join this one. Okay, so that's we meet here, and let's say this will be our H. So we join F1 to H, F2 to H, and then F3 to H. All right, so up to this point, who has any question before we move on? I mean, it's very, 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 very clumsy. So what I'm saying is that there's ground points H and G are moving this link from here to here. I mean, from this position to this position and to this position. How would that be? So the next is to do the link transformation. And the link transformation, what I'm going to do is to just change the ground point to the ground point from G and H to this, and then this one will become a moving link. How do I even join this? Okay, so we just join, let's join the GH link. So this becomes our moving link now. The GH link becomes a moving link now, and this will become a pivot link. So if we do that, Then this link is holding this here. This is holding this here. So this one become our output link. And then coming. Okay, so now I'm trying to find a way that so this one will be here. Come on. So position 1 will be here. Position 2. Position 2, where should we be? Will be here. And then position 3. Coming. So let's just go right now. I'm not being able to see. The work is very messy. I need to locate the three positions for the output link, which is the GH. All right, give me a minute. All right, let's do this. I need to sit down and then check it very well. So before we can add the diode, before we can add the diode, we need to locate the 3 positions. You know, the ground link. Now we will have the HJ as our link now. Now at position 1, we will have AG connected to the link here, and then this connected here. So at position 2, now we need to be able to transfer this line, right? All right, so this is what we're going to do. We will pause this one on this level. I believe up to this point everybody understood, right? So we will pause on this one. After this session, probably this evening, I'll take my time and go through it and send the solution to you, or probably record it and send them to you. So we will end on this, the fixed pivots on this one here. All right, so let's move on to the position analysis, which are the other assignments. Now this. Okay, so we have this one, and then this one as well. Okay, and then we have this. We're doing the drum track assignment 7, figure 1, and then figure 2. So let's work with this first. All right, so in this, I said there is a link, the linkage shown in figure 1, which is this one. It's a dump track at position 1. The hydraulic cylinder CE. The cylinder is CE. So where's the E? I'm coming. They've changed the diagrams. Okay, CE. This is hydraulic cylinder. The hydraulic cylinder CE is connected to the buckets QRAC, which is here, with at point E with a pivot. Link DE, which is this link DE here, connects the bucket and frame B, C, D at E and D. So at E and D. Okay. Link D connect the bucket and frame B, C, D at E and D respectively with pivot joints. Frame BCD, the frame BCD, so this BCD, this frame BCD and bucket QRAC are pivoted to the chassis at B and A. So they are pivoted chassis, which is B here and then E here respectively. Link DE is connected to pivots B and E. Okay, the link D is connected to pivots D and E. I think that one has been mentioned. If the bucket QRAC rotate 20 degrees clockwise to position, draw the linkage at position 2 and label all the moving pivots as script 2. On the diagram, determine the angular displacement of the hydraulic cylinder, the frame BCD, and then the link DE For each displacement, state whether it is clockwise or anti-clockwise, and then find the extension of the actuator. Okay. All right. So what they are saying is that the bucket here has rotated 20 degrees clockwise. Okay, so if we rotate the bucket 20 degrees clockwise, which is to say the length or the points here okay, let's do this. First off, I need to have a line that is rotating by an angle 20 degrees. All right. Okay, so let's just join E and E. All right, so E and E is a distance or a link joining point E and point A on the bucket. So if the bucket rotates by 20 degrees, that EA will also rotate by the same amount of angle. All right, so now that we know EA is somehow a link on the bucket, we measure 20 degrees in a clockwise direction. So you let your fix at the center of the protractor align with the center here, because that's where the rotation is happening about. The whole bucket is rotating about this point. So you put your center there, and then you make the zero line align with the EA line, and then you measure your 20 degrees, which is somewhere here. So from this pivot point, you draw a line. So that means E will be along this line. All right, so we know that the point E is going to rotate about the A at a fixed distance. So you just put your protractor here, and then here, and then maybe you can make an arc like this. All right, so make an arc. So where the line meets the straight line you drew becomes your point what? E2. Okay, now you know E2. What you also know is that the distance D to E is fixed. So just put your compass and take the measurement from D to E, and then stand at E2 and make an arc. Another thing you know is that the point D is rotating about the fixed point B. So you put your compass at the center here, and then with DB as your fixed radius, you make an arc. The D is rotating about B, so it can go this way, and then the distance between D and E is also fixed. So you take the distance from here and make an arc. So where those 2 points, those 2 arcs meet, will become your D2. All right, now the distance between D and C is fixed. So you stand here, and then you take the distance DC. Then it comes to D2 and make an arc. You also know that C is rotating about D as well. So you come and stand here as well. Come in. My compass is loose. Okay, so these are fixed points, and C make an arc. So where the arc by rotating about B meets the fixed distance DC, which is somewhere here, that will become our C2. All right, so we have E E2, E2, D2 be somewhere here. And then D2, C2 will be somewhere here. And then we have your C2B here. All right, so that is that. Now we have the position 2 for C and D and E as well. The question says we should find the angular displacement of the hydraulic actuator and the frame BCD and the link DE. So first, the hydraulic actuator CE, which is, so here will be your C2, D2, right? Maybe you can use some short dashes. Okay, and this one is the C1E1 is somewhere. So to measure the angle, maybe you can just extend them till they cross each other, and then we use that as our fixed point to measure the angle. So if I draw this line and then I extend the CE link or CE line as well, I'll have a fixed point here, right? So I'll put the protractor there. Good. And then I'm having 7 degrees. 7 degrees. So theta for CE, I have 7 degrees. And you could see that's a sort clockwise, right? So CE, theta for CE is 7 degrees and it's what? Clockwise. And then the next one is the frame BCD. Now you could see the frame BCD, if it rotates, the same angle of rotation will be for the length CB as well, right? I have not even joined D to B. I can join them as well. Let me just join. Okay, so you can just measure the angle between D1B, D2B, or C1B, C2B. They should all give you the same answer. So that's 2. You put your center there, and then you let the line align with C1B, and then you take the measurement for C2B, and that is 23. All right, so theta for the frame BCD have 23 degrees, and that is also what? Clockwise. And the last one, you are supposed to find the displacement for the length DE. Oh, that's what the first one is CE. Okay, so DE is here. DE is here. So the DE2, we have DE here at position 1 and DE2 here at position 2. So you see, it becomes a bit difficult finding the angle. So you just have to extend them until they meet, and then use that meeting point as the center of rotation and measure how this one has rotated from the other. So extend this, and then the meeting point is very far. I'm going to get a meeting point at all. Come in. We have it here. let's just try the other method we did for the other one. Because apart from that, I don't know which method we can use to measure the angle. So we need to make sure we have a fixed point to measure the angle D2 E2 is making with D1 E1. All right, and for that we need to extend the line D1 E1 and then the line D2 E2. All right, so they are meeting somewhere which is off the sheet. So somewhere here. All right, so I can stand at that point. Okay, so I have five degrees. So theta for DE, I have 5 degrees, and then that is clockwise as well. Okay, so we are done with that, and then they're asking us to find the extension of the hydraulic cylinder. So first I have to take the measurement, the CE length, which is from here to here. C1E1 is 7.8. So C1 E1 is 7.8. Then C2E2 we have 8.4. C2E2 we have 8.4. So the extension will be equal to 8.4 minus 7.8, and that will be 0.6. Oh wait, -8.4 minus 7.8. Yeah, 0.6. So you have 0.6 cm here, and they are saying that what we measure here, AB, the AB length here is 5. So AB, which is equal to 5, is equivalent to 1000 mm, right? So the extension, which is 0.6 cm, will be equal to what? Right, so that will be 0.6 times 1000 all over 5, and that will be equal to, I don't have a calculator, so I have to do it off it. So we have 0.6 times 200, 6 times 20, and that will be 120. So 120 mm. All right, so the extension of the hydraulic actuator will be 120 mm using the scale given in the question. So that's for this assignment. I mean, the assignment 7. All right. SRC week we don't learn. Okay. Don't forget, just after the SRC week is exams week. So yes, so that's that for this one. If you have any problem, let me know in the comment section before I move on to the next one. Excuse me a minute. Oh, where from the shadow? Okay, so all right, so we are going to do the last assignment and then we'll be off here. Okay, so are we good? Can you let me know in the chats? Shall we move on? Okay. All right, so assignment 8, which is the same as what we just did. So the linkage shown, in figure 2 is a dump truck at its position 1. The hydraulic actuator CD06, so CD06 is connected to the frame BCO4. So this is the frame B, where's the B? BCO4. So this frame. All right. And then also we have The hydraulic actuator CD06 connected to the frame BC04 and chassis at C and O6 with pivot. Link AB connects the buckets EFGH and frame BC04 at A and B respectively with pivot joints. Frame BC04 and bucket EFGH are pivoted to the chassis at O4 and O6 respectively, which is here and here. The O4 and O2, right? So the frame and then the bucket are connected to the chassis at O4, O2. Okay, so if the hydraulic actuator CD06 extends by 30% of its current length to position 2, draw the linkage at position 2 and label the moving joint with subscript 2, and from the diagram determine the angular displacement and all of those. Okay, let's get into this. Sorry. So this time what I'm saying is that the hydraulic actuator has extended, right? Has extended by 30% of its current length. So we are going to measure the total length C106 multiplied by 30%, and then we add to the current, or we just do the percentage increment. So from here to here, the current length is 7.2. All right, 7.2. So C106 is 7.2 cm. Okay, sorry, I think the network is not really good for me today. So C106 is 7.2, and then I'm going to increase by 30%. So as total length after extension, let me say C206 will be 130 times 130 over 100, right? Times 7.2. So it'll be 1.3 times 7.2. I don't have a calculator here. What do I do? Let's just, so 7.72, so okay. Then 13, 6, 21, 2, 7, 6, 39. So 9.36. So the new length C206 will be 9.36 cm. All right, so we measure 9.636 from the straight edge. 9.36 is approximately 9.4. So 9.4, and then you come to 06. Since the hydraulic actuator is pivoted at 06, no matter where it extends, it's going to be on a certain arc because the C is going to rotate about the 06. So you create this arc and say that the point C1 will be along this arc after the extension of the hydraulic actuator. But you also know that there's 04 C1. The C1 will also be rotating about 04, and that distance 04 C1 will always be fixed. So we take the measurements or the length 04 C1. You don't even have to move, you just have to stand at 04, and then C1, 04 C1 as your radius. You make an arc, so where they meet will be your C2, and this is where the hydraulic actuator will be at position 2. So you can just join C2 to O6, something like this. All right, so this is your C2. Now the next is to find B2, right? And you know BC, the length is what? Fixed. So you measure B and C, just have to be here. You measure B and C, or you take the lengths B and C, so we stand here, then you go to C2, make an arc. But you also know that B will also be rotating about what? O4. So you stand at B1, O4, make an arc. So where they also meet becomes what? B2. So you can join them. Okay, what next? E, right? Now the point E is having a fixed distance from B and rotating about O2. So you take the measurements B1E, come and stand at B2 and make an arc. And then O2E will rotate with a fixed distance. So you come and stand at O2 and put your compass at E, and then make an arc where they meet to become your what? A2. So we have something like this, and then something like this. All right, so we are done. We've located C2, B2, A2. So we are done. What's the next thing is to find the angular displacement of the hydraulic actuator, the frame BCO4, which is this one, the link AB, and the buckets EFG. Okay, so let's begin. So first off, we know C and D are written about this point, right? So the angle here, theta, is just the angle we are measuring as the what? The angular rotation of the hydraulic cylinder. So I believe you all know how to measure angles by now. So you locate the fixed points of rotation, and then you align the zero line with one of the lines, which is in this case C106. Then I will measure C206. So I'm getting I'm getting 8 degrees, right? So theta for C06 is what? 8 degrees, and obviously that is what? Clockwise rotation. The next is to measure the angular displacement of frame BCO4. Now BCO4, the rotation of O4C1 to O4C2 will be the same, will be the rotation of the whole frame, right? So just join C2 to O4 and measure the angle between C1O4 and C2O4. So as usual, you find the fixed point, you align with one of them. Okay, so you should extend the O4C2 so that you can see the measurements clearly, but probably might not align on any number for you. So if we do that, we have it at 52 degrees. Do well. Yeah, we have it at 52 degrees. So the frame theta for the frame BCO4 is 52 degrees, and that is what? Counter clockwise, because it's rotated this way, right? So it's going against the clock. This one went in the along the clock arm. So you found the frames. The next is BD. So the BA the BA, you just have to extend the A so that it can cross the line joining AB. So where is AB? The AB line is here. All right, so if we extend, don't do it deep though. So you just have to extend the line. Maybe short axis. You just want to find the fixed points of rotation. But without the fixed point of rotation, you can't do the measurement. So this time, you put your protractor somewhere here in the center. You align with the red line. Okay, I'm getting 6 degrees. So the angle theta for AB, I have 6 degrees, and that is also clockwise. That's also clockwise. The next one is the bucket EFG. Now the bucket EFG will rotate the same as the link or the line joining AO2. All right, so A1O2 is here, and then A2O2 is here. So the angle here, don't forget A is attached to the bucket. So as A rotates, the bucket is rotating. So the angle for the A's rotation will be the same angle for the bucket's rotation at the fixed point O2. So you put your center there, you align with one of the lines, then we have a perfect 50 degrees. It's actually 49. It's 50. So theta for the bucket is what? 50 degrees, and that is also counterclockwise. All right, so we are done with this as well. Will this section be recorded? Yes, please. Sure, yeah, so we are done with this. We are done with the last assignment as well. So like I stated earlier, I will go over the specified fixed pivot problem and then go through it again and give you the solution, probably by end of today or early morning tomorrow. Thank you so much. I mean, I've seen you guys have done well by being here, but I've seen 0 likes with what we are doing. So before you log out, kindly like what you've done today, and you've done well by giving me good interaction in the chat room. I need more likes, and then see you going tomorrow. Thank you so much. I'm out here.